Now we're going to show you how to determine probabilities from the z-scores or the x values using the TI-84. So first of all, what you're going to do is you're going to press second in distribution, which is also known as the VARS button over here. Scroll to second normal CDF because we're using a normal cumulative distribution function. Then we follow the prompts. For the lower, we're going to put in the lower value for x, which I'm denoting as XL, or the left z-score. For the upper value, put in x upper or the right z-score. For the mean, enter the mean. If using z-scores, the mean is always 0. And for sigma, enter the standard deviation. If you're using z-scores, use 1 because the standard deviation for z-scores is always 1. Scroll to paste and hit enter, and then it's going to show you the normal CDF with your lower value, your upper, your mean, and your standard deviation. And I'll go ahead and hit it now. So here you can see second distribution. Go to 2, normal CDF. You can hit 2 to go faster. And I'm going to put in the values that are currently on this part of the notes, which is 1.2 and 2.5. Now, both of these are z-scores, so I'm going to leave the mean at 0 and sigma at 1. And then hit paste and enter, and there's your value. Now, so let's go ahead and look at some examples. I want to determine the probability that the z value is between negative 2.75 and negative 1.5. So I'm going to go ahead and put that on this normal distribution here. And that would be roughly this area. So my lower is negative 2.75, my upper is negative 1.5, and my mean is 0, and my standard deviation is 1. Mean is 0 and standard deviation are 1 because I'm dealing with z-scores. Then I would go ahead and put that in my calculator and it would give me a value, and I'll do that in just a second. For the other one, I want the probability that the z value is less than negative 2.75. So it's just this piece over here. It's not going to be very high. So what is the lower in this case? Well, normally we wouldn't be too worried if we were just using the table because it goes to infinity automatically on the left. But in this case for the calculator, it needs a lower and an upper. Technically, it's negative infinity. All right. And your upper would be negative 2.75 because that would be the high value. Your mean's still 0 and your standard deviation is 1. But what you can do is you can actually have so now let's look at entering these on the calculator. So I'm using second distribution and going to normal CDF as before. Here my lower is negative 2.75 and I'll enter that. And negative 1.5. My mean is 0 and my standard deviation will be 1. And then hit paste, enter, and I get a value of 0.0638. All right, and then if we go to the next part, now I can't really enter negative infinity as a lower, so I'll use a high value like negative 1,000 or even further. And then for the upper, I'm going to put in the negative 2.75. And keep the mean as 0 and the standard deviation is 1 and hit enter. And I get 0.00298 roughly. Well, one of the advantages of using a calculator is finding the greater than probability. So it's not quite, we don't have to do the 1 minus thing that we have to do with the percentiles. So let's go ahead and look at this. We want a z is greater than negative 1.5. So if I shade that in, that would be roughly this area. My lower is negative 1.5. My upper is technically infinity. And that means on the calculator, I would use something like 1e to the 99 or just a really large number like 1,000. My mean is still 0. My standard deviation is 1 because I'm dealing with z-scores, and the mean z-score is 0 because that's how the distance from the average, and on average you're 0 from the average, and the standard deviation is 1. All right, so let's go ahead and look at the next setup. We want to determine the probability that x is greater than 3 if the mean is 2 and the standard deviation is 0.63. So if you're not having to show z-scores like you're doing the multiple choice part of the exam, then this is actually a really fast way to get your probabilities. What you can do, let me go ahead and finish filling in the model, all right? So I want the probability that x is greater than 3. So I actually have x values down here instead of z-scores. Well, that's roughly this area. So my lower is 3, and my upper is infinity, or some really large number. And be careful with 1,000. 1,000 may not be far enough if you're like looking at SAT scores with means of, who knows, in that case, the mean isn't even 1,000, or it could be, 670 or whatever. So anyways, be careful that this number is far enough away so it's really far away. Then you can actually put in the mean x value and the standard deviation for the x value instead of 0 and 1, and it will give you your values. So let's go ahead and enter both of these on the calculator. So second distribution, lower is negative 1.5. And I need a large number here, and that's big enough. Then I'm going to keep a mean of 0 and a standard deviation of 1 because I'm doing z-scores. And I get 0.9331927. Now let's do the second one. I have a lower of 3. This number is far enough away. Now I'm going to change this to 2 and 0.63 and press enter. And I get my value right there. So you can just go ahead and enter x values in directly. I would strongly recommend, if you're doing free response either on my test or AP test, please show me z-scores. I would rather have you do it this way than the second way. But if you're doing a quick multiple choice question where you don't get credit for the work and you know what you're doing and you're comfortable, go ahead and use a shortcut.